Good morning, students. I'm your Nagini ma'am. Today I'm going to discuss about the relations between the concentrations. Clear, students? This topic is from solutions lesson, students. Okay. Now I'm going to discuss about the relations between the concentrations. We know that concentrations are nine types are there. Correct? Nine types: mass percentage, volume percentage, mass by volume percentage, ppm. Next, molarity, normality, molality, mass percentage, formality. Correct? Total 9 concentrations are there. So what are the relations between the concentrations? Now we are going to discuss, students. Okay, now. So first of all, first relation, students, between the normality and molarity. What is the relation between normality and molarity? Clear this one? First relation, students. Relation between normality and molarity. Okay, normality and molarity. So what is the relation between normality and molarity? Now see, students, what is normality, students? The number of gram equivalents of the solute present in the 1 liter of the solution. Correct? That is normality. Molarity is nothing but the number of moles of the solute present in the 1 liter of the solution. That is molarity. So normality is represented by capital N, molarity is represented by capital M. Correct? So what is the relation? So first I will take normality formula, students. So normality is equal to formula weight by gram equivalent weight into 1000 by volume. It is in liters, students. Clear? So weight by gram equivalent weight into 1000 by volume, students. This is the normality formula. But we know that gram equivalent weight is equal to gram molecular weight by N. Correct? What is gram equivalent weight, students? Gram equivalent weight is equal to gram molecular weight by N. Okay, now. So N value, it is mainly for acids, N is equal to, we have to take basicity, students. For bases, N value, N is equal to acidity. For salts, nana, total charge present on cation or anion you have to take. And for oxidizing agents, what we have to take, students? N is equal to change in the oxidation number. That you have to take, students. Clear this one? So what N indicates here? N is equal to, N indicates basicity, acidity. For acids, basicity will be there. Correct? What is basicity, students? Basicity is nothing but the number of H plus ions. Okay, now the number of the number of H plus ions are replaceable in one molecule of acid by the cation, students. So that means that how many H plus ions are replaceable when it is added to the acid, is added to the water, then how many H plus ions are replaceable? That is equal to the basicity. Correct? So I'm not going to discuss about that everything, students. So just gram equivalent formula is equal to GMW by N. Clear? So small n indicates acidity, basicity. Next, total charge present on cation or anion, and another one is that is change in the oxidation number. Okay, now students, that gram equivalent weights I will take one more video, students. Okay, then you can understand about the gram equivalent weight. Okay, now for salts, how to find; for acids, how to find; for bases, how to find; suppose oxidizing agents, how to find. Everything I will discuss in the next video, students. Clear this one? This is GMW by N. Right, now here I am taking the normality is equal to this formula, students. I'm substituting here gram equivalent weight. So normality is equal to what we can write, students? Weight by gram equivalent weight kada. Weight by gram equivalent weight means gram molecular weight by N. Correct? Into 1000 by volume. Clear this one? 1000 by volume. Then N is equal to what we can write, students? This N will go to the numerator. Correct? N separately I am writing. The remaining formula is weight by gram molecular weight into 1000 by volume. It is in liters. Clear this one? Now this one, you see, students, once you observe, you can write in the place of weight by gram molecular weight into 1000 by volume. Instead of this, we can write molarity. Correct? What is molarity? Weight by gram molecular weight into 1000 by volume. Now, so that's why N is equal to small n into capital M. So this is the relation between normality and molarity, students. Clear this one? So this is the first relation, students. Okay, Namma? Now, what is the second relation, students? Relation between molality and density, students. So, what is the relation between molality? So, we know that molality is represented by small m, correct? So, molality is represented by small m. Na? So, right here, small m is equal to molality kadama. Small m is equal to weight by gram molecular weight. Molality. What is molality, students? The number of moles of the solute present in the 1 kg of the solvent, correct, or 1000 grams of the solvent. So weight, molality is equal to weight by gram molecular weight into 1000 by weight of the solvent kada. So that's why weight of the solvent nama, I am taking that weight of the solvent is capital W. So okay, now this is the weight of the solvent. Here you write, students, it is the weight of the solvent. Clear this one. Weight by gram molecular weight into 1000 by weight of the solvent, this one. So first in the I want to calculate first weight of the solvent, students. So for that sake I am taking the density formula. What is density, students? Mass by volume na. So density is equal to, we know that, mass by volume, correct, or we can write it as W by V, correct, mass by volume. So density is equal to W by V. Okay, then we can calculate W value. So weight of this is density of the solution is equal to weight of the solution by volume of the solution. Clear this one. This is the volume of the solution, weight of the solution, this is the density of the solution. Clear, students? Now weight of the solution is equal to what we can write, students? Weight of the solution is equal to density into volume, correct? Density into volume. Now weight of the solution. Solution is nothing but what, students? Solute plus solvent kada. So weight of the solution means solute weight plus solvent weight, correct? So W, I am taking here solution weight. Solution weight is equal to solute weight plus solvent weight. Clear this one. So that is weight of the solute plus weight of the solvent is equal to density into volume. This is which one, students? Density of the solution and density of the volume, sorry, volume of the solution. Clear this one. So density of the solution, volume of the solution. This is the weight of the solution now. So that is we are writing as solute plus solvent. Now I have to find weight of the solvent. Now what we can write, students, from this formula? Weight of the solvent is equal to density into volume minus weight of the solute, correct? So this is the weight of the solute, small w. This is capital W, students. Clear this one. I am taking weight of the solute is equal to small w. Take here capital letter, okay, big one, capital W. So D into V minus capital V minus W, that is the weight of the solute. Now this formula here you substitute, students, then what you will get, M is equal to, this is the weight of the solvent, okay, this is weight of the solute, students. Now this formula here substitute, then molality is equal to, small m is equal to weight by gram molecular weight into 1000 by weight of the solvent is how much, students? D into volume minus weight of the solute. Clear this one. This is also weight of the solute, this is also weight of the solute. Clear this one. So this is the formula, this is the relation between molality and density, students. Clear this one. This is the second relation, students. Now I am going to discuss about the third relation. Now see, students, third relation between molality and mole fraction. Clear? So I am taking the molality, students. What is the molality formula, students? Small m is equal to, molality is equal to weight by gram molecular weight into 1000 by weight of the solvent, correct? So I am writing formula, weight by gram molecular weight into 1000 by weight of the solvent. Clear this one. Weight of the solvent, students. This weight is solute weight, this is the solvent weight. Clear? So this formula, what I am doing here, molecular weight. With molecular weight I am here with numerator and denominator both we are taking as molecular weight, students. Okay, now molecular weight, which one molecular weight? That is solvent molecular weight. So suppose molecular weight of the solvent by molecular weight by molecular weight. Okay, molecular weight of the molecular weight by molecular weight, this both are which one, students? Solvent. Clear this one. So when we multiply this, value will not change na? Just I am multiplying with the molecular weight of the solvent by molecular weight of the solvent. Clear this one. So this is the weight of the solvent by gram molecular weight of the weight of the solute by gram molecular weight of the solute. This one is molecular weight of the solvent by molecular weight of the solvent. Now see, students, from this one formula we can write weight by gram molecular weight, weight of the solute by gram molecular molecular weight of the solute, we can take it as number of moles of the solute, correct? What is the number of moles of the solute? Weight of the solute by gram molecular weight of the solute, correct or not? That is the number of moles. So I am taking as this is the number of moles of the solute. This is which one, students? Number of moles of the solute, n into 1000 by, okay, weight of the solvent, weight of the solvent by molecular weight of the solvent. This one what we can write, students? Here see this one, this we have, this one we are writing as n number of moles, and weight of the solvent by molecular weight of the solvent means this one, this part, clear this one. So this part, this by this one is equal to what we can write, students? Weight by gram molecular weight of the solvent means that is the number of moles of the solvent kada. So here where we can write 1000 by, here this number of moles of the solvent, here I am writing number of moles of solvent. Next remaining part, what is there, students? Molecular weight of the solvent, clear this one. So this is the molecular weight of the solvent, clear this, students? Molecular weight of the solvent, okay. Then here we got number of moles of solute by number of moles of solvent into 1000 by molecular weight of the solvent, clear this one. So here I'm taking a number of moles of solute by number of moles of solvent, I'm calculating, students. Here instead of this number of moles of solute and number of moles of solvent, what we can write, students? In the form, in mole fractions we can write. So how to write, students? Here number of moles of the solute. What is number of moles of this? I am taking first of all mole fraction. See here, mole fraction of the solute. What is the mole fraction of the solute, students? What we can write? Mole fraction of the solute, number of moles of solute by total number of moles of solute and solvent, correct? This is the formula. Number of moles of solute by number of moles of solute plus number of moles of solvent, correct? This is the mole fraction of this solute. I am calculating and solvent mole fraction. What is the solvent mole fraction? Solvent mole fraction, what we can write, students? Here solvent mole fraction is equal to number of moles of solvent by total number of moles of solute and solvent, correct? Number of moles of solute and solvent, clear this one. Solute by solvent. So here I am taking as mole fraction of solute by mole fraction of solvent, I am taking, just calculating. So what value will get? Mole fraction of the solute by mole fraction of the solvent. So then what we will get, students? Number of moles of solute by, correct? Number of moles of solute by number of moles of solute plus number of moles of solvent, okay, divided by this one, number of moles of solvent, okay, divided by number of moles of what we can write, students? Number of moles of solute plus number of moles of solvent. Now this one will get cancelled. What we can write, students? Here number of moles of solute, okay, by number of moles of solvent. So that means instead of here number of moles of solute, here formula is there, number of moles of solute by number of moles of solvent. So here we can, what we can write, students? Mole fraction of the solute by mole fraction of the solvent. So here I am writing this formula, students. See here, number of moles of solute by number of moles of solvent is equal to what we can write, students? Mole fraction of the solute by mole fraction of the solvent, clear this one. So this value here you substitute, students, here in this place, okay, in this place you just substitute, okay. Number of moles of solute by number of moles of solvent is equal to the mole fraction of solute by mole fraction of the solvent. This value here substitute, then what you will get, students? Molality is equal to small m is equal to number of moles of solute by solvent means mole fraction of the solute by mole fraction of the solvent into 100 by, sorry, into 1000 by what you will get? Molecular weight of the solvent. So this is the molecular weight, students, molecular weight of the solvent, clear this one. This is the relation between molality and mole fraction, molality and mole fraction, students, clear this one, molality and mole fraction. So small m is equal to what we can write? Weight by gram molecular weight into 1000 by weight, students, weight of the solvent. This is the solute. So here just I'm taking molecular weight of the solvent by molecular weight of the solvent, just multiplying this one with numerator and denominator both. Here we are taking molecular weight only. So that's what you will get value value will get cancelled. Here value is not changed now, so that's why here this by this is equal to weight of the solute by gram molecular weight of the solute, means that is we are taking as number of moles of the solute. And this next weight of the solvent by molecular weight of the solvent is nothing but, because it is in the denominator, this value we can take it as number of moles of solvent into 1000 by, as it is molecular weight of the solvent, as it is here writing. So here this is equation 1, just you take this is equation 1 students, this is equation 1, and here we calculated this is equation 2, number of moles of the solute by number of moles of solvent we calculated. This is a mole fraction of the solute, mole fraction of the solvent. Clear? Then solute by solvent, if you calculated, you will get number of moles of solute by number of moles of solvent. So this value here we are substituting students. That means substitute equation 2, substitute equation 2 in equation 1. Clear this one? In equation 1, then you will get molality is equal to mole fraction of, in this place what we are taking, solute by solvent mole fraction into 1000 by molecular weight of the solvent. Clear this students? This is about the relations between the concentrations. Here 3 relations I discussed students. In the next video I will continue that remaining relations. Okay, I hope you like this video students. Thank you students. If you like this video, please like, comment, share, and subscribe my channel students. Okay, thank you students.